Okay, so we are going to do another Leetcode problem, and let's do it right. Okay, so the problem is to sum. So given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to target. Okay, so an array of integers, not real numbers, and an integer target, another integer, plus minus negative numbers, plus negative 0. We have these two inputs clearly, and we are supposed to output a number and a number, void. So void is I'm guessing if there is no, if it doesn't satisfy the requirement. We may assume that each input may have exactly one solution. So I guess I can assume that it's going to have one solution, and I can't use the same number twice. Can return the answer in linear order. Okay, so 2, 7, 1. Okay, the target is fine. Then it's going to be 2 and 7. So I return the indices. For this one, it's going to be 2 and 4. Okay, 3 and 3. It's target 6. It's going to be 0 and 1. So I can't just return 0, 0 or 1, 1. So it has to be different indices. Cool. The nums can, okay, so the input array can be of length 2 to 10 raised to 4, right? So it can be anything between those two or those edge cases as well. So that's fine. It's input array size and the nums array 1. Okay, so the numbers inside the array, they can be negative, they can be positive, but apparently they're all integers, positive and negative integers. That's fine. And the same thing for the target. So target can also be negative, positive to sufficiently large numbers. Okay, only one valid answer exists. So I'm going to assume that the answer can also be void, since that's what's given in the question. Let's get started. Okay, so let me just write out my test cases real quick. Console log to sum. It's going to be why don't I just run it within the editor? So I'm going to write it here and I'm going to run the tests within Leetcode. Okay, so right off the bat, I'm thinking you need to find what combination of numbers from this results in a sum that's equal to target, right? So I have to find out every single combination of two numbers that satisfies this requirement that the sum is equal to target. So I'm just thinking I can do 2 for loops, right? Because I can just find out every single combination. So for this one, I can match it with every other integer, but I have to keep in mind that I can't use the same element twice. So instead of counting every single combination as a valid combination, I have to discount the combination which is of the same element twice. Okay, so right off the bat, like I said, to for loops, that I is equal to 0. What I'm going to do is I'm going to try and find out every single combination. I less than or equal to nums dot length I plus plus. And for that, inside that I'm going to do another for loop. J is equal to 0. J is less than nums dot length J plus plus. It's another one. Now inside this, I can just so nums I is the first element in the combination. So write it down. Nums j is the second element of the combination. So since we have a condition that can't be the same element twice, I'm just going to check I is equal to j. It's going to be continuum. So using a low-level primitive like for instead of for each loop or something like that, it really helped us out because we can control. We have more access to the control flow as compared to a for each loop, which uses a callback. Okay, so when this is solution, the solution is true when these two add up to target. Okay, so if it's the solution, I can assume that there is exactly one solution. So if I find the solution, I just have to return ing, and I can call it a day. Pretty simple, right? Let's see if it works. So if it doesn't have a solution, it's not going to return anything, so essentially void. Okay, let's run it. Cool, it ran. So it works. So we're going to try the second part of this question. It's a follow-up. Can you come up with an algorithm that's less than O(n) in time complexity? Okay, so with this kind of thing, what I generally kind of have seen is that we can also use a hash map instead of finding out every single combination, right? It's because it reduces the time complexity of two for loops. So I'm guessing. So what I'm guessing we can do is we can run a for loop. Yeah, once, and we can add everything to a hash map, and then we can look at the numbers again. And once we look at a number, like if I look at 2, I know the target is 9. I know that I need a 7, right? So if I have a hash map, it's sort of like it's like data that I already know. It's like data that's been indexed, right? So I can just search the hash map for the value if it has a key 7, and if it does, that means it exists in the array and I have a solution. So since we have exactly one solution, I just have to do it once and find it out. Let's do that then. Okay, so first step is putting everything into the hash map. So I'm going to say, I'm going to create a normal object in JavaScript. It's going to be num hash map. Okay, I'm going to run a for loop. I is equal to 0, I less than nums dot length, I plus plus, and for nums dot I, I'm going to say num hash map is, so I'm going to give an arbitrary value of, let's just say true. Okay, so it has to be a truthy number, not a falsy number. It's an any type because expression of type number can be used to index type. Okay, so I have to add a type to this, which is going to be string. It's a record of number and true. Okay. Okay, so at this point we already have the hash. The data has been indexed, and all I have to do is simply run through another for loop, which should be fine. And then now inside this for loop I have to check my condition, which is the current number is nums dot I, right? So is the nums dot I, okay. So required complement. This is the number we want. So it's going to be target minus I. So num hash map dot required complement if this is equal to true, that means we have a number in the hash map that satisfies the condition. Basically we have a complement in the hash map for this number, but we also have to check that the okay, so this is because we can't have a duplicate submission, we can't have true as the value. So instead what we have to do is we have to store the index, which is also another number, and I'm going to store the index of that right inside that. So we're learning as we go. So required complement is that, and if the required complement, if the number's hash map contains the required complement, so it's going to be, I'm going to name it as required complement index is what you will get. So resultant for this is going to be a number or it's going to be undefined if the required complement doesn't exist. So hopefully type description has got this. Maybe I need to play around with the TS config. So this is going to be number or undefined. This could be anything, right? Okay. So if the required complement exists and required complement is not equal to I, excuse me, index is not I. Okay, so if it exists in the hash map and it's not the same as the same element, it's not the same element repeated, then we can confidently return I and required complement ID X. Okay, so let's try this one. And attempts. Let's try running it. Alright, okay, perfect. We got it alright. So this works. Okay, see you guys in the next one.